Hello students, welcome once again. In previous video we have seen about general introduction about soft gelatin capsule. In this video we are going to study about some formulation aspect which are related to that of soft gelatin capsule. Let's begin. So through this video you are going to get basic components of soft gelatin capsule shell, then formulation of filling material of soft gelatin capsule, then types of fill and recipients, base adsorption, and concept of minim per gram. Let's begin. The first one, that is basic components of soft gelatin capsule or soft gelatin shell, include first is gelatin. So gelatin is ideal substance for capsulation. A large number of different gelatin shell formulations are available depending on nature of the liquid fill matrix. Most commonly the gelatin is alkaline processed, that is type B, and it normally contains 40% of wet molten gel mass. However, type A acid processed gelatin can also be used. Then the next one is plasticizers. Plasticizers are used to make the soft gel shell elastic and pliable. They usually contain from 20 to 30% of wet gel formulation. The most common plasticizer used in soft gel is glycerin USP, sorbitol USP, and their combination. The amount and choice of plasticizer contribute to the hardness of the final product and may even affect its dissolution or disintegration characteristics as well as its physical and chemical stability. The next component is preservative. So preservatives are often added to prevent the growth of bacteria and molds in the gelatin solution during storage. However, methylparaben and propylparaben in ratio 4:1 and sorbic acid 0.2%. Other preservatives that are commonly employed are potassium sorbate, then methyl, ethyl, etc. Then coming to next one, that is colorants. Colorants may be added, that is soluble dyes or insoluble pigments or lakes, and or opacifier like that of titanium dioxide may be added to the shell for visible illusions and also for reducing the penetration of light for the encapsulation of the photosensitive drug. The color of the capsule shell is generally chosen to be darker than that of its content. Then the next one is flavoring agent. So depending upon the need to be achieved, flavoring agent can be added like that of ethyl vanillin, then essential oils and fumaric acid. It is used to aid solubility and to reduce aldehyde training of gelatin. Then apart from all this component, one more component which is used is water. So water usually amounts for 30 to 40% of wet gel formulation. Its presence is important to ensure proper processing during gel preparation and soft gel encapsulation. Then following encapsulation, excess water is removed from soft gel using controlled drying. So these were the various important components of soft gelatin capsule shell. Now moving to next part, that is formulation of filling materials of soft gelatin capsule. The various liquid phase filling matrices used in soft gelatin capsule are selected considering the following criteria. The first one is compatibility with capsule shell. Then next one is ability to dissolve the drug. Next one is rate of dispersion in GI fluid after shell disintegration in the GIT. Then the next one is ability to optimize the bioavailability of the drug. Then the next is types of fill or bases. So in this, the first one what we have is hydrophilic liquids. So polar liquids with a sufficient high molecular weights are commonly used. Polyethylene glycol, that is PEG, is most frequently used. For example, PEG 400, which has the average molecular weight of approximately 400 Dalton. Then smaller hydrophilic molecules such as ethanol or indeed water can be incorporated in soft gel fill matrix in low level, typically below 10% by weight. Then the next one is lipophilic liquids or oils. So triglycerides oil such as soybean oil are commonly used in soft gels when used alone. However, their capacity to dissolve drug is limited. The drugs like that of steroids, vitamin D are mixed with these oils. Then coming to next one, microemulsion system. It consists of water surfactant water system. Blend of water and surfactant together with the active ingredient is filled into the capsule. A microemulsion of lipid surfactant polar liquid system is characterized by its translucent single phase appearance. Other materials that can be filled are emulsifying oils. So, a combination of pharmaceutical oil and non-ionic surfactant such as polyoxyethylene sorbitol monooleate can serve as an oily formulation which disperses readily in the gastrointestinal fluid. The resulting oil or surfactant droplet enables a rapid transfer of drug into the absorption mucosa and subsequent drug absorption. They are also known as self-emulsifying oils. Then the next one is suspensions. So drugs that are insoluble in soft gel film matrix are formulated as suspension. The continuous phase may be any of the vehicle described. Then suspension formulations provide significant advantage for certain low solubility drugs which are very poorly absorbed after oral administration. With the appropriate choice of excipient, soft gel suspension can have improved bioavailability. So these were the various types of filling bases. Now let's talk about base adsorption. So base adsorption is number of gram of liquid base required to produce a capsule mixture with 1 gram of solid. So BA is equal to weight of base upon weight of solid. The base absorption of solid is influenced by particle size and shape, its physical state, that is whether it is amorphous or crystalline, density, moisture content, its oleophilic and hydrophilic nature. Then further, let's talk about determination of base adsorption. So weight a definite amount, say 40 gram, is convenient of solid into 150 ml tiered beaker. Then in a separate 150 ml tiered beaker, place about 100 gram of liquid base. Add a small increment of base to solid and use the spatula. Stir the base into the solid after each addition until solid is completely wetted and uniformly coated with base. This should produce a mixture that has a soft ointment like consistency. Then continue to add liquid and stir until the mixture flows steadily from the spatula blade when held at 450 angle, that is 45-degree angle above the mixture. Then base absorption is equal to weight of base upon weight of solid. Then coming to last point from this respective video, that is concept of minim per gram. So the base absorption used to determine the minim per gram factor, that is m by g of the solids. The minim per gram factor is the volume in minim that is occupied by 1 gram of solid plus the weight of the liquid the weight of the liquid base, that is BA, required to make encapsulable mixture. The minim per gram factor is calculated by dividing the weight of the base plus the gram of solid, that is BA plus S, by the weight of the mixture W per cubic centimeter or 16.23 minims. That is BA plus S into V by W is equal to M by G, that is minim per gram. Then it can be thus said that lower the base absorption of the solid and higher the density of the mixture, the smaller the capsule will be. So this is all in this video. Thank you for watching till end.